Hello everyone, good evening. So here we shall give the solutions of the maths test on congruency of triangles. So here the very first question, it is told that in two triangles ABC and PQR, angle A equals to 30 degree, angle B equals to 70 degree, angle P equals to 70 degree, and angle Q equals to 80 degree, and AB equals to PQ. No, AB equals to RP. Then which of these options are correctly applicable? The first option is triangle ABC is congruent to triangle PQR. Option B is triangle ABC is congruent to triangle ABC is congruent to triangle QRP. And option C is triangle ABC is congruent to triangle RPQ. And option B is triangle ABC is congruent to triangle PRQ. So which of these options are correct? We have to find out. So here we can see that these two triangles, triangle ABC and triangle PQR, angle A that is suppose 30 degree, and angle B is suppose 70 degree, and angle P is also 70 degree. So angle P this is 70 degree, and angle Q. So this is C. So this should be 80 degrees since the sum of the three angles should be 180 degrees. So this is angle Q. Angle Q is again 80 degree. So this is R. So PQR. So this should be 30 degree. And 70 plus 70 plus 80 is 150. So 150 plus 30, that is 1. So here we can see that, and it is also given that AB is equal to RP. AB is equal to RP. So here we can see that these two angles are equal, and this side, the common side is, means the included side is also equal. Therefore, we can see that in triangle ABC and triangle RPQ, angle A equals to angle R, which is equal to 30 degree, and angle B equals to angle P, that is equal to 70 degree. And you can see that AB is equal to RP, which is given. So therefore, we can see that triangle ABC is congruent to triangle RPQ. Since why, here you can see that angle A is equal to angle R, so it means A corresponds to R, and angle B equals to angle P, so B corresponds to P, and angle C is equal to angle Q, so C corresponds to Q. And of course, it is also told that AB is equal to RP. AB is equal to RP. So basically, we can see that we have to tell triangle ABC is congruent to triangle RPQ. So option C is the correct answer. Then in question number 2, it is told if triangle ABC and triangle DBC are two isosceles triangles. The same base BC, then then first option is that angle ABD, that is equal to angle ACD. Option B is angle ABD is greater than angle ACD. Option C is angle ABD is less than angle ABD is less than angle ACD. Option B is angle ABD is less than angle CAD. So here we can see that triangle ABC and triangle DBC are two isosceles triangles on the same base BC. So it can be like this. Can be like this, which means ABC and BBC. So we can say that suppose AB and AC are equal and BC and CD are equal. So therefore we can say that ABD. So this angle will be equal to this angle. Suppose this is X, this is also X, and this is Y, this is also Y. So now angle ABD. So here you can see that angle ABD that is equal to Y plus X, since it is ABC plus CBD, and angle ACD that is equal to X. This will be equal to 180 minus 2X. So this will be 180 minus 2X plus 1. So which may or may not be equal also. Which may or may not be equal, and this may be greater or may be less. So we can't say anything. But if it happens that ABC and DBC are such that suppose DB and DC are equal and AB and AC are equal, then only we can say that if this is Y, this is also Y, and this is X, this is also X. And then in that case, we can say angle ABD will be equal to angle ACD, which is equal to X plus Y. That we can say, but this can be the case. Suppose we call this case 2. This can be the case also, case 1. So if we consider case 1, then anything can happen. It means that Y plus X can be, which is angle ABD. So angle ABD can be more than ACD also, or it can be less than ACD also. So anything can happen. So it means that the question, so in the options are not correct. So here all the three options, case A, B and B, C, D, anything is possible here. Suppose here ABD, that is X plus Y, that can be less than CAD also. Less than CAD. CAD is this one. So it means that all the three options ABC can be true. So which means that if we consider case 2, then only option A will be correct. Then in question number 3, in the given figure, AD is the median. AD is the median. Then angle BAD is this is 35 degree. This is 35 degree. And these two sides are equal. It has been given. So here it is told that AD is the median. So it means that these two lengths are also equal. This is given as 35, but this is not given as 35. But these two triangles would be, so angle BAD is The options are option A is 55 degree, option B is 45 degree, option C is 40 degree, and option D is 50 degree. So which will be the correct option? We have to find out here. So here we can see that in triangle ABD and triangle ACD, and triangle ACD, AB equal to AC, which is given, is shown only, and AD is the common side. AD is common side, and also we can see that also BD is equal to CD. Since why? Since D is the midpoint. So D is the midpoint of BC. So therefore, you can see that triangle ABD is congruent to triangle ACD by SSS, by side rule of congruency. Side rule of congruency. So here these two triangles are congruent, so it means that angle ABD, that is equal to angle ACD, which is obviously equal to 35 degrees. And also we can say that angle ADB, that is equal to angle ADC, which is equal to 180 degree divided by 2, that is 90 degrees. So this is 90. So angle BAD we have to find out. So therefore we can say that therefore angle BAD plus angle ABD plus angle ADB, that is equal to 180 degree. Hence by using the angle sum property. So let's say angle BAD is X. So we are saying this is X. So this will be also X by CPCT. So we can say that X plus 35 plus 90, that is equal to 180. So hence it means that X should be equal to 90 minus 35. So that is equal to 55 degree. Option A is the correct answer. Then in question number 4, it's told that in triangles ABC and triangle DEF, AB equal to FD, AB equal to FD, and angle A equals to angle D. The two triangles would be congruent only if two triangles would be congruent only if A is BC is equal to PF, B is AC is equal to DE, C is AC is equal to EF, D is BC is equal to DE. Triangles ABC and triangle DEF. This is triangle ABC. AB is equal to FD. So this is F. AB is equal to FD. Angle A is equal to angle D. The two triangles are congruent only if. So here we have to use another side. So it means that if we have to use SAS rule, so if we have to use the side rule, then this angle should be the included side, should be the included angle. This angle A should be the included angle. So it means we have to take AC. So AC should be equal to DE. AC should be equal to DE, then only I can say that, then only I can say that triangle ABC that will be congruent to uh, triangle DFE. So hence AC should be equal to D. So option D is the correct answer. Then in question number 5, it has been told that in a triangle PQR, in a triangle PQR, if angle QPR that is equal to 80 degree and PQ is equal to QR, PQ is equal to QR, then angle R and angle QR, then angle R and angle QR from A that is 70 degree and 80 degree, then B is 80 degree and 70 degree, option C is 80 degree and 80 degree, and option D is 50 degree and 50 degree. So triangle PQR is given, triangle PQR. So here it is told that PQ is equal to QR, PQ is equal to QR, and angle QPR that is 80 degree. Then obviously QRP also should be 80 degree. So angle R, so angle Q, this will be, this is 160. 2 8 is 16, 160, and this is QPR that is 80 degree and PQ is equal to QR. So here, sorry, PQ is equal to PR, it is given. PQ is equal to PR. PQ is equal to PR. So it means that this is PQR. So PQ is equal to PR, that is given. And angle QPR, this is 80 degree. And R and Q are how much? So if so, these two angles will be equal only. Angle R will be equal to angle Q, since the angles opposite to the equal sides are also, the angles opposite to the equal sides of a triangle are also equal. So if I take this is X, this is also X. So then let's say this is each of them are X. So therefore sum of the three angles is 180 degrees. So 2X plus 80, that is 100, 180. It means that 2X is equal to 100. So it means X should be equal to 50. So each of these angles are 50 degrees. So angle R equal to angle Q, that is 50 degrees. So option D is the correct answer. Then we have two assertion and reasoning based questions. Question number 6, the assertion is given as the given figure, the given figure PE and CF, PE and CF are two equal altitudes. Two equal altitudes of triangle ABC, So then if there are two equal altitudes of triangle ABC, so then triangle ABE is congruent to triangle ACF. Then the reason is if two angles on one side, two angles on one side of one triangle are equal to two angles and the corresponding side, two angles and the corresponding side of the other triangle, then the two triangles are congruent. Then the two triangles are congruent. So here in the assertion it is told in the given figure, the figure is this ABC, triangle ABC, and BE and CF. BE and CF are two equal altitudes. These two are altitudes, and then we have to prove that triangle ABC is ABE will be congruent to triangle ACF. So that is true only since why angle A is the common angle, and these two angles are equal, and B and CF are two equal altitudes, and B is going to CF. So I will say that in triangle ABE and triangle ACF, we can say that BE is equal to CF, which is given. BE is equal to CF, which is given, and angle AEB, that is equal to angle AFC. Since why both are equal to 90 degree, which is given only. Since why both of them CF and BE are altitudes. And we can say that angle A, or you can say angle BAE is equal to angle CAF, since which is equal to angle A, which is the common angle. So I can say that we have used angle, and the non-included sides are equal in these two triangles. So I can say that triangle ABE is congruent to triangle ACF by angle side by AS rule of congruency. AS rule of congruency. AS rule of congruency. So therefore, hence the assertion is true. And then the reason is that if two angles and one side of a triangle are equal to two angles and the corresponding sides of the other triangle, then the two triangles are congruent, which is also true. So here actually we are using that two angles and the side. So here they have explained the AS rule. So we are actually using the AS rule only. So hence the reason is the correct explanation of the assertion. So the reason is also true and the assertion is also true, and reason is the correct explanation of the assertion. So option A is the correct answer. Since both A and R are true and R is the correct explanation of A. Then in question number 7, it is told the assertion. The assertion is given as in triangle ABC, B is the midpoint of DC. B is the midpoint of DC. So DL is perpendicular to AB and DM perpendicular to AC. such that DL is equal to DM, and then BL and BL is equal to CM. Then the reason is given as if two angles at the included side, two angles at the included side of one triangle, two angles on the included side of one triangle are equal to two angles and the included side of another triangle, two angles and the included side of another triangle, then the two triangles are congruent. Then the two triangles are congruent. So here in triangle ABC, in triangle ABC, it is told that D is the midpoint, it's triangle ABC, and D is the midpoint of BC. If DL is perpendicular to AB, DL is perpendicular to AB, and DM is perpendicular to AC, DM is perpendicular to AC, such that DL is equal to DM, DL is equal to DM, then BL is equal to CM also. That we have to prove. So here it means BD and CD are also equal since D is the midpoint of BC. So here we can say that these two sides are equal. DL is also equal to DM. But here actually we have to use the RHS rule. So here I can say a triangle BDL and triangle CDM. Angle BLD, that is equal to angle CMD, is equal to 90 degrees, which is given that DL and DL is perpendicular to AB and DM is perpendicular to AC. And BD is equal to CD since it is given that D is the midpoint of BC, and also DL is equal to DM. DL is equal to DM. DL is equal to DM. Since that is also given. So here we can see that in these two right angle triangles, one side and the hypotenuse are equal. So therefore I can say triangle BDL, that is congruent to triangle CDM by RHS rule, of congruency. By RHS rule of congruency. RHS rule of congruency. So, so it means that the BD. So hence I can say that therefore BL, that is equal to DM, or BL, that is equal to CM. BL, that is equal to CM by CTCT. So hence the assertion is true. But the reason is not true, since in the reason it is told if two angles and included side of a triangle equal to two angles and the included side of another triangle, then the two triangles are congruent. So in the reason they are explaining the angle side angle, which is the ASA rule of congruency they are explaining. So it means that the reason is also true, but it is not the correct explanation of the assertion. So hence option B is the correct answer, since here both A and R are true, but R is not the correct explanation of A. Option B is the correct answer. Then in section B, the question number 8 is told that in triangle ABC, the bisector AD of angle A is perpendicular to the side BC, then show that AB equal to AC. That AB equal to AC. Now here we have to draw that triangle first. So here that in triangle ABC, the bisector AD is perpendicular, so it means that these two sides are equal. The bisector AD of angle is okay. So it is the angle bisector. It is the angle bisector. We can't say that D is the midpoint. We can't say that. Yeah, but obviously we can say that angle A is divided into two equal halves by AD, since AD is the angle bisector of angle A. So it means these two angles are equal, and this is perpendicular to BC. Then we have to show that AB is equal to AC. So obviously, I would say that in triangle ABD and triangle ACD, angle ADB that is equal to angle ADC, since both are right angles, that is 90 degrees, since it is given that AD is perpendicular to BC, which is given. And obviously angle BAD that is equal to angle CAD. Angle BAD that is equal to angle CAD. Angle BAD is equal to angle CAD. And BAD is equal to angle CAD. Angle BAD is equal to angle CAD, which is given since by AD is the bisector of angle A. And obviously AD is the common side. AD is the common side. So here we have proved that two angles in these two triangles on the included side are equal. So therefore I can say that triangle ABD is congruent to triangle ACD by ASA rule, by angle side angle rule of congruency, by ASA rule of congruency. So hence we can say that hence AB equal to AC. AB equal to AC by CBCT. So hence proof. Then in question number 9, it is told that E and F are respectively the midpoints. E and F are respectively the midpoints E and F are respectively the midpoints of equal sides, AB and AC of triangle ABC. Figure is formed. Then we have to show that EF that is equal to C. EF equal to C, we have to show. Now the triangle given is like this. This is AB and AC. So AB and AC are equal sides. And E and F are the midpoints. E and F are their midpoints. Sides AB and AC. So to show, so then BF and C we have to join. EF and CB. So BF equal to C that we have to show. So now here, so first we have to write what is given. Given and to prove we have to write and how to prove it. The proof is that you see that in triangle ABF, and triangle ABF and triangle ACE, triangle ABF and triangle ACE, AB equal to AC, AB equal to AC, which is given, and AE, we can say AE is equal to half of AB. Since it is given that E is the midpoint of AB. E is the midpoint of AB, which is given. Similarly, we can see that KF is half of AC, since F is the midpoint. F is the midpoint of AC, which is also given. So we can say that since AB is equal to AC, so half of AB also will be equal to half of AC. So hence we can also say that A is equal to AF, A is equal to AF, and angle A is the common angle, means angle BAF is equal to angle CAE, which is since angle A is common, angle A is common. So therefore, we can see that AB and AC are equal and KF is equal to AF. So I can say that triangle ABF is congruent to, so two angles, we have, so two sides and the included angle are equal in these two triangles. So and triangle ABF is congruent to triangle ACE by SAS rule, by side angle side rule, by SAS rule of congruency, by SAS rule of congruency. Therefore, we can say that EF is equal to CB by CBCT. Therefore, BF is equal to CE by CT. So hence proof. Then in question number 10, it has been told that triangle ABC is an isosceles triangle. Triangle ABC is an isosceles triangle in which in which AB equal to AC, the side BA is produced, side BA is produced to D such that AD equals to AD, so that AD equals to AD. So see the figure. So the figure is like this. Trigonometry is an isosceles triangle and which AB equal to AC. This is ABC. It is given that AB equal to AC. The side BA is produced to D such that AD equals to AB. That AD equals to AB. So then we have to show that angle BCD is a right angle. Angle BCD is a right angle. How to prove that? Since this is an isosceles triangle, so these two angles are also equal. If this is x, this is also x. Similarly, these two sides are equal, so the opposite angles are also equal. If you take this is y, this is also y, and the sum of the three angles is 180, so x plus y should be 90. So how to write the proof? So we will write the proof like this. That is that in triangle ABC, AB equal to AC, which is given. So we can say that so angle ABC that is equal to angle ACB. Hence, the angles opposite to equal sides of a triangle are also equal. And the angles opposite to the equal sides of a triangle are also equal. Similarly, in triangle ACD, AC is equal to AD since y both are equal to AB. Since both are equal to AB, which is given. Both are equal to AB, which is given. So, so I can say angle ACB that is equal to angle ADC. Since here also the reason is same, since angles opposite to the equal sides of a triangle are also equal. So angles opposite to the equal sides of a triangle are equal also. So therefore, now let us take angle ABC equal to angle ACB that is equal to x, suppose say. And similarly, angle ACD that is equal to angle ADC that is equal to y, suppose. So now you can say that angle BCD that is equal to angle ACB plus angle ACD. So that will be equal to ACD that is y and ACB that is x, so y plus x. So now I can say now in triangle BCD, angle BCD plus angle DBC plus angle DCD plus angle BDC that is equal to 180 degree since according to the angle sum property of a angle sum property of a triangle. So now we can say that angle BCD that is equal to x plus y, angle DBC that is equal to x plus angle BDC that is equal to y, so that is equal to 180 degree. So therefore I can say x plus y plus x plus y, so that is x plus x that is 2x plus y that is 3y, that is equal to 180 degree. So therefore I can say 2 into x plus y that is equal to 180 degree. So therefore I can say x plus y that is equal to 180 degree by 2, that is 90 degree. So now we can say that angle BCD, angle BCD, angle BCD that is equal to 90 degree. Since x plus y is BCD. So hence proof. Hence prove that angle BCD is a right angle. Now in question number 11, it is told AB is a line segment. AB is a line segment and the line L is its perpendicular bisector. Line L is its perpendicular bisector. If the point P lies on L, the point P lies on L, then show that P is equidistant from AN. P is equidistant from AN. So here the diagram is somewhat can be somewhat like this. So it is told that this AB is a line segment and line L is the perpendicular bisector of it, which means that this is line L. So this is perpendicular to AB and it divides AB into two equal halves. So I can say if this point is suppose C, I can say AC is equal to CB and P is any point on this perpendicular bisector L, and we have to show that P A equals to PB. Means we have to say so that P is equidistant from M. Simply here we have to prove that PA is equal to PB, or which means that P is equidistant from M. So how to write the proof? So in the proof we will say that in triangle ACP and triangle BCP, angle ACP that is equal to angle BCP that is equal to 90 degree. Since it is given that since PC or I can say L is perpendicular to AB, which is given, and this AC is equal to PC, which is also given that L bisects AB, and also we can see that PC is the common side. PC is the common side. So we can see that triangle ACP that is congruent to triangle BCP by we have used two sides and the equivalent angle. So by SAS rule of congruency, these two triangles are congruent. So therefore, we can say that PA is equal to PG by CBCT. So hence proof. So hence it is proved that the point P is equidistant from the points A and B. Then in question number 12, it is told the two sides AB and BC, two sides AB and BC, and median AM of one triangle ABC are respectively equal to sides PQ and QR, and median PM triangle PQR. Then you have to show that. Then you have to show that first part is triangle ABM is congruent to triangle PQN. Second part is triangle ABC is congruent to triangle PQR. So these two have to show. So here is given that two triangles ABC and PQR. Now AM is the median, so M is the midpoint of BC. Similarly, N is the midpoint of QR, so PN is the median of triangle PQR. So here it is given that AB is equal to QR, AB is equal to PQ, and BC is equal to QR, and PN AM that is equal to PN. AM is equal to PN. So now, how to prove the first part? We have to show here that now the proof, I will say that in triangle ABM and triangle PQN, AB is equal to PQ, AB is equal to PQ, which is given, and AM is equal to PN, which is also given. And similarly, and BC is equal to QR, which is also given. So I can say that half of BC, that will be equal to half of QR, which means since M is the midpoint, we can say BM is also equal to half of BC. Here you can see that PM is equal to half of BC, and obviously QN is equal to half of QR, which is given only that since AM is the midpoint, AM is the median on BC and PN is the median on QR. So obviously M is the midpoint of BC and N is the midpoint of QR. So therefore I can say that BM is equal to Q1. So hence we can see that in this triangle PQN, AB is equal to PQ, AM is equal to PN, and PM is equal to Q1. PM is equal to Q1. So hence we can say that triangle ABM is congruent to triangle PQN. Triangle ABM is congruent to triangle PQN by SSS, by side rule, by SSS rule of congruency. So hence the first part has been proved part one. And then the second part we have to prove, that is, so from here we can say that, so we can say angle ABM that is equal to angle PQN by CPCT. Or we can say angle ABC, since ABM and ABC are equal, so angle ABC that is equal to angle PQR. Now, so hence we can say that now in triangle ABC and triangle PQR, ABC and PQR, we can see that AB is equal to PQ, AB is equal to PQ, which is given. and C is equal to QR, which is also given. BC is equal to QR, which is also given here. Also given. And triangle AB and angle ABC, that is equal to angle PQR, which is proved earlier, or I can say proved above. Proved above. So you can say that triangle ABC is congruent to triangle PQR by SAS rule of congruency, by side angle side rule of congruency. Since we have shown that two sides and the included angle in these two triangles are equal. So I can say triangle ABC is congruent to triangle PQR by SAS rule of congruency. So SAS rule of congruency. Now, so hence the second part has been proved. So part two. Part two. So now, question number 13. Question number 13, it has been told. Question number 13 has been told that AB is a line segment. AB is a line segment. AB is a line segment. And P is its midpoint. P is its midpoint. And D and E are points. D and E are points on the same side. D and E are points on the same side of AB. Says that angle BAD, that is equal to angle ABE. Angle BAD is equal to angle ABE, and angle EPA, that is equal to angle DPB. And DPB. So that triangle DAB is congruent to triangle EBP. The second thing is AD is equal to BE. AD is equal to BE. AD is equal to BE. So here it is given that AB is a line segment. AB is a line segment and P is its midpoint. P is the midpoint. D and E are points on the same side of AB such that angle BAD. Okay. It means that this angle BAD, that is equal to angle ABE. Will you take some derivatives to no. No, no one said. They say to take it on Monday. Then what did they do? Yeah, only class means from 1:30. Where I was in engineering. Means from what they did nothing. Means they only just study. You should have taken place out. Yeah, I haven't created it. Tomorrow also they are fails. I totally think wrong with like otherwise there is a stress. So so on which day I'm like next. I didn't Saturday will take like will take 2 days for tomorrow. If that's clear, last day. So I only told you on Tuesday I will make you inform them. Otherwise there will be no means many were absent. That is not a problem. That is our duty is to take. That is not a problem if they are absent. Because this process is not just very specific to me. Tomorrow it will take some time to inform. So tomorrow I can take. It was the PP days it was told you have to take clients out. You should have sorry, sorry. So here is ABE angle BAD is equal to angle ABE. These two angles are equal. And PPA equal to DPE. P is the midpoint. So these two sides are. So we have to show that triangle BAP is congruent to triangle ABP. How to prove it? We have to prove the proof is like this. We have to write in triangle BAP and triangle ABP. Angle DAP is equal to angle DAP is equal to angle ABP. Since why it is given the AB is equal to BAD and angle DPA is equal to angle DPB also. Since why is angle EPA that is given equal to angle DPB. So I can say that 180-degree minus angle EPA, which is equal to angle EPB, that is also angle equal to angle EPB, and that is also equal to 180-degree minus angle DPB is equal to angle DPA. So, and AP is equal to DP since it is given that P is the midpoint of AB. So therefore, I can say that triangle DAP that is congruent to triangle EDP. Triangle DAP is congruent to triangle EDP by angle side angle, like ASA rule of congruency. The ASA rule of congruency. So now you can say that AD is equal to B. It is equal to B by CPCT. So hence B. Then in question number 14, it is told that in right angled triangle ABC, right angled at C, M is the midpoint. M is the midpoint of the hypotenuse. Is the midpoint of the hypotenuse AB. He is joined. He is joined to M and then produced to a point D. He is joined to M and produced to a point B, such that DM is equal to CM. And point D is joined to the point B. Point D is joined to the point B. And show that first thing is triangle AMC is congruent to triangle BMD. Second is angle DBC is a right angle. Third is triangle DBC is congruent to triangle ACD. Fourth is CM is equal to half of it. So the figure is like this. D A B C is M. M is the midpoint of AB. E is right angle. M is the midpoint. E is joined to M and produce the point D such that EM is equal to CM. Point D is joined to B. Now here the proof is like this. So that angle AMC that is equal to angle BMD. Since they are vertically opposite angles are equal, since they are vertically opposite angles, AM is equal to BM. So we should say this in triangle AMC, in triangle BMD. The triangle AMC that is equal to BMD, these two are vertical opposite angles, AM is equal to EM, which is equal to obviously half of AB, which is given also. AM is the midpoint of AB, and CM is equal to DM, equal to half of CD, which is given also. So I can say that triangle AMC is congruent to triangle BMD by SAS rule of congruency. Since we have used two angles and the two sides and the included angle. Since two sides and the included angle in these two triangles are equal. So by SAS rule of congruency, these two triangles are congruent. Now, we'll see that angle MAC is equal to angle NBD. So angle MAC, you can say that is equal to angle MBD, hence y by CBCT, and also AC is equal to BD by CBCT. So hence the first part has been proved to part 1, that triangle AMC is equal to triangle BMD. So now here we can see that angle AC is equal to angle MBD. So therefore we can say that AC is parallel to BD. Since the alternate interior angles are equal, alternate interior angles which are angle MAC and angle MBD are equal, and obviously AB is the transversal. AB is the transversal. So hence AC is parallel to BD. So I can say that angle CBD, that is equal to 180 degree minus angle ACB. Angle CBD is equal to 180 degree minus ACB. Since why? Co-interior angles are supplementary. Co-interior angles are supplementary as AB AC is parallel to DB. We have proved it. So hence CBD that will be equal to 90 degree. Or I can say that angle DBC is a right angle. Angle DBC is a right angle. So hence proof part 2. Second part has been proved. Now we can see now in triangle ACB, and triangle DBC, ACB and DBC, you can say that angle ACB that is equal to angle DBC that is equal to 90 degree, which is proved earlier. ACB equal to DBC that is equal to 90 degree, which is proved earlier, or I can say proved above. And you can say that DC is the common side. DC is common side. The figure was like this. This A, B, C, D. This is A, B, C, this is D. So we have proved that these two angles are right angles. BC is the common side, and also we have shown that AB equal to, no, sorry, AC is equal to DB, which is proved above or proved earlier. So we can say that these two sides are equal. This is a common side. So I can say that triangle ACB is congruent to triangle DBC. ACB is congruent to DBC by SAS rule. By SAS rule of congruency. So I can say that AB equal to CD. I can say that AB is equal to CD by CBCD. Therefore, we can say that CM is equal to DM. So this was M. And CM is equal to DM, which is given. Into DM, which is given. So I can say that half of AB that is equal to half of CD also. Which means that M So I can say CM, which is equal to half of CD, and AM, which is equal to half of AB. CM is equal to AM. Or we can say that CM is equal to half of AB. So hence part 4. Part 4 has been proved. And triangle DBC is congruent to triangle ACB. So this also has been proved. So this is also right. This is proof part 3. Then in question number 15, it is told that in a housing society, complex, central car has to be developed. Central car has to be developed. The shape of the central the shape of the central car is shown in the figure. The shape of the central car is shown in the figure. Is a square ABCD, and CD is an equilateral triangle. CD is an equilateral triangle. The side CD, the square ABCD. EBA, the working track. EBA is the working track and the form of the triangle CD. EBA is the working track in the form of the triangle EBA. Then based on the above information, based on the above information, given figure, answer the following questions. Answer the following questions. What is the measure of angle BC? Prove that triangle ADE is congruent to triangle BC. State the type of triangle AED. Give reason. So here ABCD is a square. Then here CDE is a equilateral triangle. So A E and PE we can join. And then you have to find the measure of angle BCE. So now angle BCE, we can see that this is angle. So each of these angles is a right angle since it is a square. And each of these angles is 60 degrees since why it is an equilateral angle. So all these sides are equal. This is equal to this, all these are equal, which means that AB equal to AD, which is equal to CD, which is equal to BC, which is equal to again B, which is equal to C. So all these side lengths are equal. So these is an equilateral triangle. So each of these angles is 60 degree and each of these angles in the square is a right angle. So therefore I can say angle BCE that is equal to angle BCD plus angle BCE. So angle BCD is 90 degree, angle BCE is 60 degree. So 90 plus 60 that is 150 degree. 150 degree is the answer for part 1. So similarly in the second, prove that. So in the second part we can say that in triangle ADE, triangle ADE and triangle BCE, can see that angle BCE that is equal to angle ADE. Since we both are equal to 90 degree plus 60 degree, that is equal to 150 degree. And also AD is equal to BC, which is also equal to DE. And or we can say this is given since y ABCD is a square. Also we can say that DE is equal to CE since it is given that CD is an equilateral triangle. So therefore, I can see that these two sides are equal and the included angle is also equal in these two triangles. So I can say triangle ADE that is congruent to triangle BCE by SAS rule, by side angle side by SAS rule of congruency. By SAS rule of congruency. SAS rule of congruency. So hence proof. So hence it is proof that triangle AD is congruent to triangle BCE. And in the third part, it is asked to find the type of the triangle AEP. So from here we can say that so AE that is equal to BE. AE that is equal to BE since by CPCT. So hence you can say hence in triangle AEB, triangle AEB, AE is equal to BE, which is proved above. Is proved earlier or proved above since triangle AD is congruent to triangle BCE. So hence you can say hence triangle AEB is an isosceles triangle. Triangle AEB is an isosceles triangle. Since the reason is since its two sides are equal. Since its two sides are equal. So hope all of you understood the solutions of all these 15 questions. Still any doubts if you have, please write them in the comments. We shall obviously clarify them. So thank you everyone. Bye.